You might have been asked to solve x plus y squared in school, and you would find out that this is just x squared plus 2xy plus y squared. But what if you keep increasing the power? So let's go x plus y to the power of n. The solution is known as the binomial theorem. First, let's start with x plus y cubed. When you expand it, you will get x cubed plus 3x squared y plus 3xy squared plus y cubed. You might see and recognize these numbers as 1, 3, 3, and 1, which can be seen in the Pascal's triangle of 1, 11, 121, 1, 3, 3, 1 here. Once you recognize this, you will find that it also happened in this one, 1, 2, 1, the coefficients. Now, to prove this, we will actually break this into steps. So, x plus y cubed, which is none other than x plus y times x plus y times x plus y, is equal to, if you multiply all the x's first, xxx plus xxy plus xyx plus xyy plus yxx plus yxy plus yyy. Now, one thing you'll see here is from each one of these factors, there will either be an x or a y taken out. So no matter what, there's going to be 3 factors in each of these. So the first one is xxx because there's 3 x's taken out from each of these. One thing this could be known as is reorganizing the letters x and y. This can be seen as how many times you want to take x. So we have 3 possible slots from each factor, and then we can choose how many x's we want. So let's say for the first one, x cubed, we want all 3 x's. So from 3, we're choosing 3 x's. And this is equal to 1. So, as you can also see, the coefficient of x plus y to the power of 3, the coefficient of x cubed, is just 1. Now, what if we try to find the coefficient for the term x squared y? Now we have 3 slots, and we want to choose 2 x's, which is equal to 3 factorial over 2 factorial times 1 factorial. And this is equivalent to 3 times 2 times 1 over 2 times 1, which is equal to 3. And yeah, that's the coefficient over here. So what if we generalize this? So x plus y to the power of n, and we want xn plus xn minus 1 y1, right? Now we want to find the coefficients. So in x to the power of n, or any of these terms, there are n x plus y factors. So there are n slots total. Now, since you have n slots, let's choose how many n's we want, right? We want n, choose n x. Or you can also think of this as n, choose 0, y. So what we're going to do here is we'll put in front of this n choose 0 as the coefficient. Now, let's find the coefficient for the term xn minus 1, y1. To find this, we have again n slots, and now we're choosing 1 slot for the y. So we're going to put n choose 1 as the coefficient. Now let's say we keep going, and now we have x to the power of n minus k, yk. Then the coefficient will be n choose k, ky's. And then this will go all the way till n choose n, x n minus n, which is just 0, and y n. So as we can see here, when we simplify it, x plus y to the power of n is equal to n choose 0, xn, plus n choose 1, xn minus 1 y1, plus all the way to n choose k, x n minus k, y k. And then once you get to n choose n, y to the power of n. This is known as the binomial theorem. Thank you and be creative.